In section 10.8 we get used to or introduced to imaginary numbers and some complex numbers, and so up until this point in this course and past this point in this course, things like the square root of -1 are just quantities that are undefined and we can't deal with it. And now what we're going to do in section 10.8 is try to deal with it in a fashion. And what we're going to do is we're going to say that the square root of -1 is going to be called from here on out small I. And these are imaginary numbers, and I guess the I can stand for imaginary numbers. So the square root of -1 is small I. The square root of -2 is going to be the square root of 2 times the square root of -1. It is going to be the square root of 2i. So if you see the square root of -2, just think of it as a regular square root of 2 times I being this. So if you have the square root of 17, the square root of -17, you can write it as the square root of 17 times I. Alright, now, the main fact about this square root of -1 is that if you multiply it by itself, you get -1. That means, since this is I and this is I, that means that I times I, or I to the second power, is -1. It's all very, very strange. So I to the third power would be I times I, which is -1, times I, which would be minus I. And I to the fourth power would be I times I times I times I. These two make a -1. These two make a -1. That's +1. So if you have I to the fourth power, you get back to +1. So what does all this have to do with really almost anything? Well, we're going to learn first of all how to manipulate these I values, and then in the next chapter we'll actually use them for a little bit of something, not much. So let's learn how to first of all mix these I values with actual numbers. So if you have a regular number and then a plus or a minus sign and then some kind of an I number, notice with a minus sign, if you wanted to, you could write it this way. So if you have a number plus one of these I values, these imaginary values, the combination of these two, a kind of mixture of regular numbers and imaginary numbers, these are called complex numbers. And complex numbers have a lot of uses, and there's a lot of beauty in them, hidden in them. But we're not going to get to use them very much. This is just an intro unit, so we're going to learn how to do a little bit of arithmetic with complex numbers. Notice a complex number in the book can be written a plus bi, where a is a regular number, no i's at all, and b is a regular number, but it's a b times an I. So here a would be 4 and b would be -3. So the first thing that you can learn to do with these kinds of numbers is you can learn to add them or subtract them. And when you're adding or subtracting these complex numbers that look like binomials, it's exactly as if the i's were x's. There's just no difference. You just add like terms. So if these were x's, you'd still do 4 plus 5 being 9, and a -3 plus a +7 would be +4 of the i's, and you would be done. So adding these two kinds of things is no big deal. But multiplying them together is kind of a big deal, because you've got to do FOIL, and it looks like it's going to be normal. Watch this. This times this would give you, I'll just write 4 times 5 for now. And this times this will give you 4 times 7 times I, and this times this will give you minus 3 times 5 times I, and this times this will give you minus 3 times 7 times I times I. So this is 20. This is 28 i's. This is minus 15 i's. And this is minus 21 I squared. This is 20. 28 take away 15. 28 i's take away 15 i's is 13 i's, but watch out. I squared, that's I times I, that's negative 1. Right here it is. I times I is negative 1. So this is negative 21 times negative 1. That's positive 21. And then lo and behold, we've got these two regular numbers that are like terms. And so look at this. We multiplied two numbers that were in the a plus bi form, that were complex numbers, and when we were all done, we got a complex number out of it, an a plus a bi. And if you stare at these numbers and stare at these numbers, it's not real obvious why you're getting these numbers. There's a lot of work hidden in there. And so multiplying two complex numbers is quite a bit of work, but it does follow that FOIL pattern, so it's not completely new and different. But be careful of the I squared. It has to be called negative 1, and then you have to do some more work and get a regular number and combine it with this regular number. So what about 4 minus 3i over 5 plus 7i? You can think of this as a fraction, or you can think of it as a division of two complex numbers, the top complex number divided by the bottom complex number. And the question is, how can you do this and get a complex number for an answer? What do we do? Do we do some sort of weird long division, or what do we do? And the answer is, you kind of rationalize the denominators. So you're going to multiply top and bottom by the complex conjugate of this. Complex because it's a complex number. Do you remember what conjugates were? They were the same values, but with the opposite sign in the middle. And what you do to the bottom of a fraction, you got to do to the top of the fraction. Now what this does is, multiplying two complex conjugates together gives you a regular ordinary number. So let's do this. 25. Positive times a negative is a negative. 7i times 7i is 49i squared. Notice the 35i and the minus 35i are canceling. On the top, we just get a bunch of stuff. 4 times 5 is 20. 4 times negative 7i is minus 28i. Negative 3i times 5 is minus 15i. And this times this is 21i squared. So, on the bottom, this is negative 1, so a negative 49 times a negative 1 is a positive 49, and 25 plus 49 is 74, so we're getting 74 on the bottom. On the top, this is 21 times negative 1, that's minus 21. 20 take away 21 is negative 1, and we have negative 28. 8i minus 15i, that's minus 43i. That's actually a pretty good looking answer, but we really want this form because we want to show that we've divided one complex number by another complex number and have a complex number. So we're going to take the 74 and distribute it in each of the denominators. So we're going to have negative 1 over 74, which is a regular number. It's no i's in it, no complex number parts. And then minus 43i over 74. So a, in this case, would be negative 1 over 74, and b would be negative 43 over 74. And so we've divided two complex numbers and got a complex number. So briefly, that's about all you need to know about complex numbers. There's one other thing I would like to do with you, and that is help you analyze stuff like this. What's I to the 83rd power going to be? Well, we know that I to the 4th power is 1. So there's going to be, I to the 83rd power is going to be a whole bunch of i's multiplied together. In fact, there's going to be 81 of them. But every group of 4 multiplied together makes 1. So the question is, when you take out as many 4's from there as you can, 4 i's and 4 i's and 4 i's, each of those will be 1 times 1 times 1 times 1. The question is, what's the remainder? Well, 83 divided by 4 goes in 20 times, and the remainder is 3. So there will be 20 groups of these 4, and each of the 4's will be a 1. So we'll have 1 times 1 times 1, blah, 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 20 of them. And then there'll be 3 leftover i's. So I to the 83rd power is going to be I to the 80th power times I to the 3rd power, and that's going to be 1. So all we really need to know is what is I to the 3rd power, and that's what this will equal. Well, I times I is -1, times a 3rd I would be -1 times I is a negative, and 1 times I is I. So it's going to be -I. All right, I think we're done.